Hello, my name is Carlos Valle. I'm a Master of Computer Science Data Science candidate. I'll be done next month, and I'm a little bummed that we won't get to participate in convocation or commencement this year. So for this project, I'm gonna do a concept walkthrough in R and RStudio for multiple choice test item analysis. I thought this would be interesting because I get to describe an algorithm on something that's relevant to all of us, and I do have a little bit of a background on that. I did employment tests. I developed employment tests for local law enforcement organization for about 13 years. So here we go. So before a test developer can create a test or can guide the creation of a test, they would go through the body of knowledge. In this case, it's a course content. If you think about everything that's taught in a semester, try to put everything on a test, you'd have a very large test. So you need to employ a sampling strategy and get the most important, try to get the most important concepts down, and then so that you can go ahead and start guiding subject matter experts to create test questions. Real quickly, here we have the anatomy of a test question. We call them, test developers call them items because they're not always questions. For instance, here we have a prompt and we call that the stem. And Idaho is widely known for its, and that's not a question. So then we have the alternatives here. All these make up the alternatives, and then we have 3 distractors, which are the incorrect responses. So wheat and corn and apples. And then we have the correct response, which we call answer or keyed response, potatoes. Once the test is given to many test takers, test developers can use those response patterns to do a couple of things. They can evaluate test questions, the quality of those test questions, and it's something that should be doing, and they can rank test takers. So it's a dual purpose. So the focus of this walkthrough will be on the stats that you get from classical test theory on question level. A full analysis gives us stats for test level. For instance, is an 81% meaningfully better than an 80? Can your test really tell apart, or is there too much underlying unreliability in that to be able to distinguish between an 81 or an 80? So the full analysis will be able to give you that, but I'm not going to go into that here just because of the time. So before we go into the analysis, I just wanted to make sure to highlight that variability in items will lead to variability in the test. Variability is vital, and you'll see in the next slide why that is. So the first metric at the test question level is item difficulty, and that's the proportion of test takers that answered the question correctly. So if 100% of the people got that correct, you'd have a 1. If 0% got that incorrect, you have a 0. And 0 variability is undesirable. You don't want to get everybody getting it incorrect or everybody getting it correct, because if everybody got it, if 1 means that everybody got it correct and it's not telling you anything, it's not giving you more information on the test takers. If everybody walks out with 100 and you're trying to select people for a program based on their test scores, you don't know more about the group of test takers if they walk out all with 100. So variability is something that's desirable in this test. The next concept is item discrimination. That's measured with item total correlation. So we would correlate a test question with the total, a test total, and high positive correlation is desirable. This means that good performers on the test are more likely to get the question right. And that's the behavior you would expect from a test question. No correlation means that it's pretty much random who is likely to get the item correct, and we don't want that. We don't want good and bad test performers to do equal chance of getting that correct. Negative correlation means that good performers were more likely to get that question wrong, which sometimes can occur just because naturally can occur, but it could mean that the test question was miskeyed or the wrong key was applied. So it was marked as an A that was correct, but it should have been D. And when you relook at the test content, you see that you applied the wrong key. So the first thing we want to do when we get our test results back is once we give the test, we can organize the data in a data frame like this, where we have each row being a student and each column being a test question. And then we'll have a student's response patterns here. So this is how they responded. So for our question 1, they got an A, D, C, C, D, C, and C. And so we want to convert that to a scoreable data frame. And we do this with the key. So we apply the key. So here, this person got, the first question was A, the key is A, so they get a point. And then they get another point because they got D as their second question. The second person got that incorrect, so they got a 0. And so we convert this data frame into this data frame. And so here's the code to do that. This is where we load our data frame. This is our raw data. We take the key out, the ID out. We load the key in, the string of correct and incorrect lines, and then we create an empty data frame so that we can create that new scored data frame, that 0, 1 data frame. And this is the code that actually does that. We have a nested loop. The outer part of the loop, it goes through every student or every row. And then the inside part of the loop goes through every column, which is a test question. And then inside we have a test condition where we say, does that part of the key match that part of the cell? If that's correct, you get a true. If it's false, you get a false. And then this converts true and false into 0 or 1. And then that gets stored into that particular part of the data frame. So once we have that converted, it's pretty easy to calculate the item difficulty. So it's pretty much just the mean of your column means. And you get something like this here, where you have the first question had almost 90% of the people getting that correct. Second question had about 70%, meaning the second question was a bit harder. Over here you can see we have question 49, only 10% of the test takers got that correct. So we would want to look at the content on that to see if there's something wrong with this question. Being hard is not, and there's nothing wrong with it being hard, it's just we just got to review the content. So when we end up with the data frame with zeros and ones, it's real easy to calculate the sum. We can calculate the sum of the row to get the person's score. We can calculate the average of these to get the difficulty, item difficulty for that particular item. The next concept is discrimination, item discrimination. So we want to be able to tell, discriminate between good and bad performers. So first, I added a column called total, because we need to correlate every item with the total. And then here we have a for loop where it goes through every item, item 1 through the total number of items, and it correlates that item. So this would get replaced with the iteration, and the total is here. So we want to correlate these two variables, and then append that to a list of correlations. And then if we print that, we get this. So question 1 has a 0.3% correlation, which is decent. Question 2 has a 0.51. As you remember, question 2 is a little bit more difficult, but it's also discriminating better. We have a case here where you have about a 0 correlation, which means that good performers and bad performers are having an equal chance of getting question 49 correctly. So maybe we want to take a look at that content because it has a poor discrimination statistic. And so what we did in the past slide was to correlate column, which is an item, with the total, right? And then we go to the next one, and we do it with the total, and then we go to the next one with the total. And this is pretty much what that for loop was doing, all right? Correlating this item with the total, correlating this item with the total. So correlate this column and this column, go to the next one, and then go to the next one. So I wanted to thank you for sticking with me. I just wanted to mention that my code will be up, but it's not necessary. There's plenty of resources out there to do item analysis if you're interested. The code that I created was just for the walkthrough purposes. And thank you.